non-analog, so digital about information processing, even in the brain. Even though it's based on analog architecture of ion channels and all those things, there is something essentially digital in the way the coding works. That would be the, I think, the most general answer. Now,
it's not so much about digital, it's just the preference for 2 versus 3.
Oh, that I don't think that 0-1 versus 0-1-2 is not a, I mean, nobody would really think that we are that binary. You know, the idea that a 0-1 code is the only way to solve information processing problems is that's a historical accident because we build silicon devices that do this. So if we made switches that were different, I'm sure we would use different ones.
What if you cannot observe the output? For example, if you keep telling the system, right, and it triggers also a series of internal processing, but the output is not observable.
Give me an example.
I can mask whatever I'm thinking. I cannot.
So that would be the, of course, so Freudian psychology in general assumes that there is potentially conscious information that is currently unconscious. So repression, all of those things. Right? So all the Freudian mechanisms are not, see, what's interesting about cognitive unconscious is that it's even in principle unconscious. So I have no access to how my brain area B1 is doing processing. It's happening. I am only aware of the output. But the Freudian account of the mind is your traumas, whatever it is that happened in your childhood could potentially come up to consciousness but are currently submerged. It's an iceberg model. Now, I mean, so all of Freudian psychology is a response to the person, right? Which is you try to extract it out of the unconscious. I mean, assuming that it is potentially conscious, we try to figure out. Whenever you have a hammer, everything looks like a nail. But my point is there's nothing wrong with that. If it's a deep, powerful idea, why not apply it to other things?
You said that our eyes are combined to give images, 3D kind of thing. One thing is that our brain generates spatial as well as temporal data. So we always forget the time information. We treat it as a random. In each case, it is mathematics where that's the main lack of this subject. So how one should get a time information of a processing or in interaction of the environment or anything else?
The answer is we don't know. I mean, in the sense that if you look at all these accounts of information processing, they are also thermodynamic processes, right? So, which is to say, and in fact, they're explicitly designed to be so because you're extracting, information out of something which intrinsically may not have it. So, the images don't have 3D; you have to extract 3D out of it. If so, there must be a thermodynamic cost. I mean, you're doing work, so the work must have some cost. But we don't have any account of what is that cost. At least in in physics, thermodynamics, you can tell me what's the efficiency of a machine. People have tried to formalize this account of what is the efficiency of information processing. But that is typically done in sort of loss rates. So how many, like if I have 2000 bits of information, I'm extracting 17. I've wasted 1983. That's a very poor way of, I think, formalizing this. Because that assumes that the bits were the stimulus. But if the bits were not stimulus, then that's not what you're losing. So we actually don't have good ideas of idealized creative models of what are the inputs to the mind and what are just it's too early. It would be wonderful to have that.
So if I understand, computation is getting some input, processing it, and giving some output. Do materials do computation?
Yes. I mean, in the same way that your silicon in a computer does computation. I mean, computation is just one, I mean, the software end of your material is doing computation.
So the materials do have mind.
Now, that's a big leap. That's a big leap. That's a big leap. Let's put it this way. Think about all of them as models. Why I say that is, planetary motion can be modeled using second order differential equations, using Newton's laws. So can economic flows. Okay? That doesn't mean that money will hit you on the head and kill you. It might, but chances are paper money won't. Okay, so my point is, therefore, you should distinguish between what modeling technique you use and what reality you attribute to it. If you mix two things, so for example, if you say, yes, materials can be modeled using computational models, brains can be modeled using computational models, therefore, but brains have minds, therefore materials have minds. I mean, that's too much. Okay.
But kind of.
In the same way that I can say planets can be modeled using differential equations, and monetary flows can be modeled using differential equations. Therefore, planets must be money. I mean, that you can't do that. Right?
Because you claim the theory says anything can be converted into a computation flow.
Yes.
If I accept that.
But that doesn't mean that they're all the same. Meaning, just as everything can be modeled using dynamical systems or differential equations, doesn't make all those things the same. It just means that you have a modeling technique that's universal.
You can wear the same spectacle to see different things. That doesn't mean they look the same or they're the same.
It's a good instrument. Right? So you can use telescopes to pry on your neighbors, and you can use telescopes to look at the heavens. But your neighbors may not be that happy.
So there is something that distinguishes apart mind apart from computation.
Well, that's so. An extreme view would say, because A can be modeled using computers and B can be modeled using computers, A must be the same as B. Now, what's interesting, and so where you are right to some extent, is if you look at the foundations of computation itself, if you look at Turing's, the whole mathematical development of computation, that's exactly the way it goes. It basically says, and Turing's idea of the Turing test also goes that way, if I can't distinguish A from B using my modeling technique, they are equally intelligent. So, which you would never say about planets and money. But you seem to be capable of saying that about people and computers. But it can be argued against for exactly the same.
Physicists investigating the nature of reality and so on. There's one school of thought, shut up and compute. Forget about reality. So why doesn't cognitive science take a very realistic approach? Shut up and compute.
In practice, that's what it does. So these foundational questions, are we really computers or not? In the history of cognitive science, maybe 2 people have gotten 10 years for thinking about that, right? I'm just saying, it's really, you don't do a job because you ask or answer those questions. So in a very practical sense, that's not the driving thing. But if you remove it, there's nothing left. What is important is, okay, practically speaking, yes, you don't think about whether mind is a computer all day long. But if you, at some level, feel like that question isn't interesting, the field itself stops asking that question, then you might as well go to Wall Street and ruin other people's lives.
No, there is an in-between state in the sense that there is probably an existing paradigm of computing which doesn't fit the way the For instance, given the question of parallel qualia. So there's an existing paradigm of computing which does not explain some of the things that minds do.